In this video, we will be doing a proof in 3D involving perpendicular lines to planes, congruent segments, congruent triangles, and all of that. So first, we have the givens in the proof here. They are also down here. We will run through the proof here and write it out on the figure over here. So first, AE is perpendicular to plane M, given. AE is perpendicular to this plane here. Next, angle ABC is congruent to angle ACB, given. So angle ABC over there is congruent to angle ACB over here. And then AB is congruent to AC if angles then sides. AB is congruent to AC if angles then sides in an isosceles triangle. From there, AE is perpendicular to BD and CD, line, plane, foot. So if a line AE is perpendicular to a plane M, then it is perpendicular to every line in that plane passing through its foot. So these two segments here. From there, angle ADB is a right angle and angle ADC is a right angle. Both perpendicular lines form right angles. So angle ADB and angle ADC are right angles. From there, angle ADB is congruent to angle ADC because all right angles are congruent. From there, AD is congruent to AD, reflexive property. So any segment is congruent to itself. Then triangle ABD and triangle ACD are congruent, HL postulate. So you can see we have right angles here and here. And then we have a hypotenuse and a leg, hypotenuse and a leg on each of these triangles. So from there, and we will switch to green to keep everything straight. Angle BAD is congruent to angle CAD, CPCTC. So angle BAD up here is congruent to angle CAD over there. So you have to envision the 3D, the marking up here goes behind this face here, and this marking goes right on this face. And then AE is congruent to AE, reflexive property. So AE is congruent to itself. Then triangle ABE is congruent to triangle ACE, SAS. So we have the red single mark, the angle, and then this reflexive side. Red single mark, angle, reflexive side. So SAS, side angle side. From there, BE is congruent to CE, CPCTC. So BE right there is congruent to CE right there. And therefore you can see triangle BEC has two congruent sides. So triangle BEC is isosceles, definition of isosceles triangle. As always, 3D takes a lot of envisioning. Just work it through several times.